The next thing we will do is we will find trig function values by using reference angles. In the lessons prior to this one, we have talked about finding trig function values, but we've always assumed that our theta value is acute. In this lesson, theta is not necessarily acute. Okay? Now there's a big deal having to do with reference angles. For any trig function, the value at theta, the original angle, is the same as the value at theta sub r, the reference angle, as long as you specify which quadrant theta sub r is located. Let me show you an example. Let's say that I would like to find the sine of 150 degrees and the cosine of 150 degrees. The first thing that I will do is I'll draw a picture. 150 degrees we know is located in quadrant 2. Now, it's my goal to create a right triangle in quadrant 2. So I will drop a right angle down from the terminal side to the closest x-axis. What that does is it creates a reference angle in that triangle. In this case, the reference angle, the original angle is 150 degrees. The reference angle is 180 degrees minus 150 degrees, which is 30 degrees. So I'm going to go ahead and label that inside my angle. Now, because this is a 30-degree angle, this means that I have created a known triangle. And I can label all my sides. The side that's closest to the 30-degree angle I know is the square root of 3. Because I'm in quadrant 2, however, this side being an x value is going to be negative square root of 3. The hypotenuse I know is 2, and then the other side is going to be 1. In quadrant 2, the y value is going to be a positive 1. And so I've labeled now the sides for my triangle. Okay, the sine of 150 degrees is the ratio of y over r. In this case, y is positive 1, r is 2. So the value is 1/2. Now what I said above, the big deal, is what allowed me to do this. In other words, I know that the sine of 150 degrees is the same thing as the sine of 30 degrees as long as I specify that I am in quadrant 2. Okay, let's now go and let's find the cosine of 150 degrees. The cosine of 150 degrees is equal to the ratio of x over r. In this case, my x value is negative, so I'll have negative square root of 3 over 2. Okay, my big deal, what allows me to find this is I know that cosine of 150 is the same as cosine of 30 degrees as long as I specify that I'm in quadrant 2. If I don't specify that I'm in quadrant 2 and I say that the cosine of 150 degrees is equal to the cosine of 30 degrees, that is absolutely not true. 30 degrees, if I don't specify where that is located in quadrant 1. The cosine of 30 degrees in quadrant 1 is going to result in a positive value. The cosine of 150 degrees, as you have seen here, results in a negative value. So if you don't specify which quadrant you're in, this problem is absolutely going to be counted wrong if you're not being careful. Okay, now I'd like to talk about a few other things. Knowing which quadrant my reference angle is located will allow me to determine the sign of my trig function. Let's look for an example at tangent. Let's say that we know that we have a reference angle and it's located in quadrant 4. Okay, and I'll go ahead and I'll draw that so that we can see what's going on here. So we have an original angle whose terminal side ended up in quadrant 4, and then we knew that our reference angle is in that quadrant. If I want to know the sine, the SIGN of tangent of theta sub r, I can do that without actually knowing any numbers. So if I look at tangent of theta sub r, and I want to know what is its sine, then what I can do is I can think about, well, in quadrant 4, what are the values of x, y, and r going to be as far as positives and negatives? Okay. Over here, if I create a right triangle, I know that my y value is going to be negative. I know my x value is going to be positive. I know my r value, no matter what, is always going to be positive. And so in this case, what's going to happen is tangent of that reference angle in quadrant 4 is going to result in a negative y value over a positive x value, and so the entire value of the trig function for tangent is going to be negative. In the text, they may encourage you to memorize which quadrants certain trig functions are positive in. I'm going to discourage you from doing that. The less you can memorize and the more you understand, the better off you're going to be. So if they're asking you to compute a trig function and they're asking you to compute a trig function in quadrant 3, you should be able to tell from the x, the y, and the r values what the SIGN of those trig functions are going to be based on the quadrant you are in. So I'm going to discourage you from trying to memorize any of those things. Now, I'd like to look at a couple of other examples. These examples are just going to be finding trig function values given particular information, and that information is going to tell you that you're not necessarily looking at an acute angle for theta. Okay, if tangent of theta equals 3 and sine of theta is less than 0, I want to find cosine of theta. Okay, the first thing you want to do is look at the trig function value they gave you. So they've given you that tangent of theta is equal to 3. If that's not a ratio, write it as a ratio. So 3 could either be rewritten as 3 over 1. Now keep in mind that tangent is y over x. So you could either have a positive y and a positive x, and that results in a positive 3, or you could also have a negative 3 and a negative 1. That would also result in the positive 3. Now, there's two places that these two values can happen. You have to nail down which of those two places it would be. Where are you going to have a positive y value and a positive x value? That's going to be in quadrant 1. Where will you have a negative x value and a negative y value? That will be in quadrant 3. How do I know which one of those values to choose? Well, to figure out which value to choose, look at this other piece of information that they gave you. They tell you that sine of theta is less than 0. That means that sine must be negative. If sine must be negative, if you think about sine as the ratio of y over r must always be positive. So the only way that sine is going to be negative is if the y value is negative. Well, which quadrants are the y value negative in? Well, it's negative in quadrant 3 or quadrant 4. Okay, so from the initial information from tangent, you were able to tell you're either in quadrant 1 or quadrant 3. From the other information, you know you're either in quadrant 3 or quadrant 4. Find where those two things overlap. Those two things overlap in quadrant 3. That nails down which quadrant you're located. Now, once you've nailed down which quadrant you're located, then go and draw a picture. So I know I'm in quadrant 3. Okay, I need a right triangle where my y value is negative 3 and my x value is negative 1. From this information, I can find my r value. So use the Pythagorean theorem. Okay, in this case I'll have negative 1 squared plus negative 3 squared is r squared. Okay, this would result in 10 on the left side. And then taking the square root, you'll get r is equal to the positive square root of 10. The value for r will always be positive, so you want to choose the positive root. So there's square root of 10. Now this question asked you, given this information, find the cosine of theta. We are now ready to answer this question. Cosine of theta, we know is the value x over r. The x value in this case is negative 1. The r value is square root of 10. Okay, to finish off the problem, we need to rationalize the answer. And so the final answer would be negative square root of 10 over 10. This concludes the lesson on finding trig functions for theta values that are greater than 90 degrees.